Hey guys, so this will be on JVM Beam Interop and how to make these two virtual machines talk to each other. So to begin this, I've got a couple of assumptions about this audience and a baseline level of knowledge about Elixir, unfortunately, just so that I can talk about this topic. First of all, I'm going to assume that everyone hopefully knows a little bit about the basics of message passing in Elixir. That kind of have the basics of distribution in Erlang, be that, and that although it sounds very lofty, really all that means is you know what a node is. And if you can send a message between two shells, you'll be fine with this talk. And even if you don't, you still should be pretty fine to follow along. There isn't going to be a whole lot of code. You can kind of squint your eyes at it and hopefully it'll all look pretty readable. Qui suis-je? That's my really bad French. Je m'appelle Kendal. I really enjoy kickboxing and Mexican food. I just moved to Montreal last week. Mon français est Paris, so I'm going to not say any more French for the rest of this. I am trying though, but it'll be a while until I can hold a basic conversation. I've been a software developer for the last 6 years. I've been writing Elixir for the last 2. I lied, it was in my description 3, but I looked back and it's actually only about 2 years. This is my first Elixir commit. I checked a couple days ago, and to my surprise, it was from 2015. I've been using it in school projects first, hobby projects, and more recently, I used Elixir to power a game server for a programming competition called Battlesnake. So 2015 might not sound like that long ago, but we have to remember that this was back when Elixir 1.0 had just been released. And we've enjoyed 29 releases since then. A lot has changed since then, most of it for the better. We just recently got support for dates, so that's great. We've started to see a lot more adoption as more businesses are scaling up past the boundaries of simple web applications into other spaces like the Internet of Things, mobile applications, API-based services, and embedded devices. Businesses and individuals are facing a lot of new technical challenges in these spaces that they weren't used to seeing before. There's a lot of potential solutions to fill these gaps, things like Kubernetes and Docker. Everyone loves to use lots of buzzwords. Among those possible candidates to fill this gap is Elixir and the Erlang virtual machine. Many people are seeing the merits of the Erlang virtual machine now and how it can help them. Things like fault tolerance, distributed systems, and concurrency. I'm not going to talk about any of this today though. But it's really important to keep in mind that Elixir is not a silver bullet. It's not going to solve all your problems. You can't just make everything concurrent and hope that everything's going to turn out great and you're going to get a gigantic speed up, or it's going to solve all your problems. Elixir is not without its own problems. I've listed a few that I know of on the slide. In my opinion, we don't talk enough about Elixir's drawbacks as a community. And while it's great to evangelize all the great things that Elixir and the Erlang virtual machine can do for us, for an ecosystem to mature, we really need to be a little bit more humble about our shortcomings and the areas that Elixir can improve. And while I can't offer you solutions to all these things right now, I can at least help you with the last item on this list today. So, like it or not, Java remains the most popular programming language in the world, and it has been for quite some time. This means that there's a lot of corporate resources that have been invested into the JVM over the last couple decades, and there's a lot of specialized software that exists on the JVM. Some of my personal areas of interest, and this is what led me into this space, is things like artificial intelligence and constraint solving. This is a highly developed area on the JVM that has very little support in other areas. One of the lesser known features about the Erlang virtual machine is that it actually has a lot of built-in support for the JVM. So this is the role of a package called JInterface. JInterface is a package that provides Erlang with the ability to communicate to the JVM And the official Erlang docs describe JInterface as such. The JInterface package provides a set of tools for communicating with Erlang processes. It can also be used for communicating with other Java processes using the same package, as well as C processes using the Erl interface library. The set of classes in the package that can be divided into two categories: those that provide the actual communication, and those that provide a Java representation of the Erlang data types, end quote. I'm not going to talk too much about number 2 on this list today, because it's extremely boring, tedious, and just not very fun. You can look at the docs yourself. It's very straightforward. It's just very, very, very boring. Instead, we're going to take a detour here and focus on how JInterface allows us to communicate with the Erlang virtual machine, or Beam. So message passaging is a supported method for inter-process communication on Erlang's virtual machine. And so it's natural that we're going to see support for this inside of JInterface. JInterface allows you to communicate with local or remote process IDs and register names like you would in Erlang. Message recipients can be Erlang processes or instances of JInterface's mailbox equivalent, mbox. You'll unfortunately see that everything is very poor Java style naming inside of JInterface, so just gonna have to get used to it. It provides data types for things like nodes, mailboxes, supports sending messages and receiving messages through mailboxes. Again, the lovely name spacing here: Com Ericsson, OTP Erlang, OTP node, lots of stuff like that, and it just gets worse. So I'm not going to hopefully talk a whole lot more about that sort of stuff. For posterity, let's just rip through the full feature list. So mapping of Erlang types to Java, encoding, decoding, and sending Erlang terms, connecting to a distributed Erlang node, using nodes, mailboxes, and EPMD, sending and receiving Erlang messages and data, remote procedure calls, linking to remote processes, compiling your code to use with JInterface, and tracing message flow. So that's all great. We see that this promises that it can do a whole lot of different things, but how do we actually use it, right? Our first step here is there's a lovely Java package called otp-erlang.jar, and you have to find that so that you can write some Java that can talk to Erlang. To do that, it's fairly straightforward. We find where Erlang is installed on our computer. I'm not going to tell you how to install Erlang. Hopefully you got it installed already. Follow your operating system's instructions. You can also compile from source. Important note there being that if you compile it from source, you're going to have Java already installed for it to compile the jar for you as well. I've run down many deep rabbit holes on that, trying to get proper versions of Java to work with it. So I would probably advocate for using the prepackaged version if you don't want to go through that. So we find where Erlang is installed. There's a library directory under there. It's got all the different libraries that are packaged with it as well. The magic one is JInterface. Your version may differ. And then underneath that, there's a private directory and otp-erlang.jar. Alternatively, you can fire up an Erl shell or Elixir if you want, and run this little snippet, code root_dir, and that'll give you the same directory that this Erlang distribution was installed in. Our second step here is we're going to start EPMD. Now, EPMD, you probably haven't heard of it, even if you've been working in Elixir and Erlang, probably because you haven't had to know what it is. EPMD is man page, describes it as such. It's a daemon that acts as the name server on all hosts involved in distributed Erlang computations. When an Erlang node starts, the node has a name and obtains an address from the host OS kernel. The name and addresses are sent to the EPMD daemon running on the local host. In a TCP environment, the address consists of the IP address and a port number. The node name is an atom of the form name add node. The job of the EPMD daemon is to keep track of the node name listed on each address. Hence, EPMD maps symbolic names to machine addresses. So that's a lot of words. What does it mean? The short of it is that when you fire up multiple instances of the virtual machine, they register with the EPMD, so they know what to talk to what. And so when you send a message to an address, it knows which machine address that correlates with. All right, so now that we know where this jar is located and we've started EPMD, we can write our Java program. All right, so here's a bunch of code. It's an example echo server written in Java. I also hate it when presenters put up a bunch of code on a slide and actually expect me to read the thing. It's not going to happen. Don't worry though, we're going to actually step through this. So this is the actual important part here, step by step. A lot of that is just boilerplate. What we actually need to do here is we need to import the classes from this jar. For the sake of brevity, we're just going to import everything, although you'll probably do that in production anyways, because who are we kidding? We're going to create an OTP node. This registers the name of the machine with an address under EPMD. We're going to create a mailbox. This acts as the same as a registered named process in Elixir or Erlang. So when you do things like send name with a message, it's the same sort of thing like that, or it would be equivalent to another process ID. Then with our mailbox, we're going to wait and we're going to receive a message. This is actually a blocking operation, unfortunately. So this is just going to hold tight until it actually gets something. Otherwise, it's never going to do anything. Here, we're going to make some assumptions as to what we actually got here. Because Java is statically typed, we have to convert everything into Java, OTP, Erlang, JInterface, equivalent types. This is where things get very not fun. So we're going to skip over this. Again, we're going to make some assumptions here. We're going to assume that we got a 2-element tuple. First element of that tuple is a process identifier that we're going to send a message back to. And we're going to assume that the second value in that is going to be the value that we're going to send back to them. And then we're going to send it back to them, because why not? So we've got our lovely Java code there in all its splendor. So we need to compile a thing. So this is probably the most important part and would cause loads of frustration if you haven't done Java before. You need to append the jar onto your class path. This is not an elegant solution, of course. There's plenty of much better build tools. I'm going to do it just like this for ease. And then we're going to run the same thing. Again, we have to add OTP Erlang.jar onto our class path here. We had a file main.java. We compile it. The main class was called main. We're going to specify that's the main function entry point when we execute the virtual machine. And then if we had EPMD still running, we would notice that it got registered with a couple different things there. So underneath we see that registering JVM to a specific port, blah, 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 blah. So we can see that the node was created, it's registered itself with EPMD. And then we're going to test it. So we're going to fire up an interactive Elixir REPL. We're going to name it. We're going to give it a short name. We're going to give the name of this node IEX. We're going to ping our JVM node. We called it in the previous example JVM. My local host is called Pandora, so I've used that as my host name there. And we see that there's a response from it. We see the message Pong. If it had not been online, we would have received pang or nothing. All right, so that's really boring. We're gonna send something a little bit more interesting here, but not a whole lot more interesting. We're just gonna play into our assumptions that we made as to what gets received. In our previous example here, we're going to send a message to our registered mailbox, inbox, with the name of the node that we specified before, JVM. We'll send a 2-element tuple. Like we said, we had made that assumption before. And we're going to send the first element being self for this current REPL, or the process of this REPL, and the second value being echo. And we see once we've flushed the contents of our mailbox in the shell, we get the value of echo, and then also OK, because that's what flush returns. And voila, that's the gist of it. Obviously, I've glazed over a lot of the meteor bits, which is kind of the data type conversion, stuff like that. Again, it's not interesting, so it doesn't make for a very good presentation. Hopefully this is enough to give people some legs to run on if they have interest in using the JVM with their existing Elixir. This is really just to provide the glue. That's all this is. Okay, so in summary, we found out what OTP Erlang.jar is and how to create a JVM-based node and how to send and receive a message from the JVM to the Beam virtual machine. And that's it.